Welcome back, Logan. For today's installment of Math from the Couch, we're just going to focus on circles again. We're going to look at it from a different way, different perspective. We're going to talk about it as a transformation, very similar to last time. I just want to make sure that it's more solidified as an idea, and it's going to carry over to in how we graph most things. All right, so the first thing is when you're dealing with transformations, you need to have a parent graph or a parent function. In this case, we have a parent equation. So this guy right here, this x squared plus y squared equals 9 is what we're going to call our parent. So this is our parent equation. What that means is everything's going to be founded or it's going to originate from this graph. Now the graph of x squared plus y squared equals 9 is where the 9 gives us a radius of 3 and it has a center located at 0, 0 or the origin. Now, the idea is that from this x squared plus y squared equals 9, what we can do is we can take this circle and we can move it anywhere we want using just the equation. So let's say we took the circle and we moved it to perhaps right there. You'll notice that the radius of the circle didn't change. So it still has a radius of 3, which means the 9 is intact. But what has changed is that it's moved to the left 3 spaces and then moved up 4 spaces. So for me, something that I might keep in mind is that we went to the left 3, right? So we went to the left 3 spaces, and then we went up a total of 4 spaces. So that transformation is going to be where x has 3 added to it, and the y has 4 subtracted from it. But the 9 is still there because it's still the same exact radius. Now, one of the questions I often get is why is it plus 3 when it went minus 3? And it's actually a little bit more convoluted. It's a little different, but my explanation usually comes down to this, is that to take our circle and move it back to the center, back to the origin, what you have to do is you have to move it 1, 2, 3 in the positive direction, and then 1, 2, 3, 4 in the negative direction. So that whole plus 3 and minus 4 is how we get the circle to go back to its original form or the origin of the graph. All right, so now let's say the circle was not located over here, but was located over here instead. So on this one, the idea is that we're going to shift it over. So this problem is a little bit different, but same premise, right? Still, same exact radius of 3, except now it's been moved 1, 2, 3, 4, 5 spaces to the right. So we're going to go 5 to the right, and then it goes up 2, 1, 2. Okay. So for us, we're going to still use our parent graph, x squared plus y squared equals 9, because the radius hasn't changed, and it's going to be x minus 5 to the power of 2 plus y minus 2 to the power of 2 equals 9, the same exact radius. All right, so this is exactly how we're going to be looking at all our problems. Let's take a look at another example. Let's suppose that we had this circle over here. So on this circle, x squared plus y squared equals 36, that is going to be our parent. So our parent is x squared plus y squared is equal to 36. Different from the last parent because the radius this time is 6, which means we have a circle located at the center with a radius of 6. And we can do the same exact thing. So what I'm going to do, instead of moving the circle first, let's talk about what happens if we had a different equation. So what if we had x plus 2 squared plus y minus 3 squared equals 36. Notice it still uses the same parent because the radius, the shape of it doesn't change. So our shape is going to be still the same thing. And then what we're going to do is we're just going to move our circle so that it follows that parameter. So we have x plus 2. That means we're going to move 2 spaces to the right. Left 2. So that takes care of the x plus 2 part of it. And then we have y minus 3, which means we're going to go up. So we're going to go up 1, 2, and 3. And very easily we can graph the circle by just moving the parent graph. All right, last problem that I want to take a look at today is this one. What is the equation of this circle? So first thing I'm going to do is identify what the parent of this graph is. So we'll start off with the parent of the graph. Now the parent of this circle has a radius of 1, 2, 3, 4. So we know that our radius is 4. So I'm going to write that. The radius is 4. Now if the radius is 4, that means we're going to be using x squared plus y squared is equal to 16. And then from here, the next thing we're going to want to do is we're going to look at how we shifted the graph. So there's two ways you can do it. You can either talk about how we can shift the graph back to the origin, which means going down 4, and to the right, to the left 2, sorry, or we can talk about just where the location of the center is. So we can look at it that way. It's up to you on how you want to look at that. So I'm going to say this. The center is located at +4, +2, so at 4, 2. So we're going to go 4 spaces to the up, sorry, 4 spaces up, and then it was 2 spaces to the right. So what we do is we just write down x minus 2 to the power of 2 plus y minus 4 to the power of 2 is equal to 16. All right, take a look at the problems, and if you have any questions, please hit me up on email or Google Classroom. You can also drop by office hours or class hours. Hope you guys do a good job with this. It's not too complex. It's very similar to what we did yesterday. And then we're going to take this and we're going to use this as our springboard to jump into quadratics and how we graph quadratics. Have a good day.